Hello, welcome back to Chapter 13, Section 5, where we're dealing with the law of sines, and we're trying to use the law of sines to, what we mentioned, solve a triangle. Which means if you give me three of the measurements out of the 6, we should be able to find the other 3. Let's connect this with geometry that we know so far, okay? So here are your congruency whatever book you would be studying, so it'd either be a postulate or a theorem. But here's the congruencies that you know from geometry. So you got angle, side, angle. Now, angle, side, angle is what we're using for the law of sines, because the side that is, the angle that is opposite of that side, I can figure out because the two angles add up to, all three of them add up to 180 degrees. So you saw that with like the last example that we did in the previous video. I had 2 of the angles and the side that's between them, and then we could figure out the other angle, and that gives me my ratio for my law of sines. Okay, we got that. Now we also have angle, angle, side. Now that's not a congruency that you learn about in geometry, but it is, because again, this would be like an angle, another angle, and then a side that's not between them. But you can figure out what the other angle is, and actually then that angle would go over here, and then I got angle, side, angle, which becomes this one. Both of these are what we just dealt with the law of sines. As a matter of fact, the title of it was Law of Sines for Angle, Angle, Side, and Angle, Side, Angle. Okay. Now, we also know side, angle, side, and side, side, side from geometry. These two will come up next in the next section, 13.5. Excuse me, I'm in 13.5, 13.6, which is the law of cosines. So we're going to save these two for later. So what are the ones that you never hear about? Well, actually, you probably did hear about this one, angle, 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 but this one's not a congruency. It's a similarity. I can have 2 triangles that have congruent corresponding angles, but they could be completely different sizes. So one thing you have to notice is I need at least one side in order to have congruent pairs of triangles. Okay? The last one is what we're going to be dealing with now. And I'm going to write it this way: side, side, angle. Now, side, side, angle becomes hypotenuse leg, and you probably remember hypotenuse leg, in a very certain situation. Side, side, angle actually becomes hypotenuse leg if the angle is 90 degrees. In this section, we're going to explore what happens if it is not 90 degrees. So let's break this down, okay? So let's say that I've got so let's say I've got angle A, and I've got side A, which is opposite, and I've got side B. Now, I'm going to start by drawing some triangles to show you what's going to happen. This is going to be one side of my triangle, but I don't know how long it is, so I put dot, dot, dot here. This is going to go this direction. I might have drawn it too far. I don't know. This is going to be my angle A. And for now, let's just let angle A be acute. We're going to look at acute. This is going to be my side B, because again, I'm going to have an angle and a side and another side. And just because I don't want to get in trouble, I'm not going to call it ASS, okay? Now, check this out. What happens if the other side here, A, is too short? And it doesn't reach. It's like you try to stretch it, but it doesn't reach this other side. That means that I get no triangle, okay? But what do I mean by it's too short? Shorter than what? Well, now I have to introduce, going way back to the first thing I talked about, which I'll grab that paper here real quick. This one, we got to go way back to the height of the triangle, right? Now I'm going to draw this in, actually, to be honest, I'm going to switch it up a little bit. I'm going to draw it in red just to make it a little obvious. If I drop that, the shortest distance between this point and this line is going to be a perpendicular. This is now the height, which we call h. And if A, side A, is less than the height, sorry, I almost said side h. I didn't mean that. All right? Then I get no triangle. And how do I figure out how do I figure out what h is if I only have that angle and that side? Well, if I use a triangle where I do have a right triangle, going back to what we said, HL, hypotenuse leg, for this one, then I got h over b equals sine A. So I'm going to write that up here. So sine of A is going to be h over b, which tells me that h, the height of the triangle, is going to be whatever b times the sine of angle A is. So if side A is less than whatever b times sine of angle A is, I don't get a triangle. Now, let's stretch side A out a little bit more. I'll start off with my same picture here. Okay, I don't know how far this side is. And this is going to be, whoops, move that up a little bit, sorry. This is going to be my angle A, and this is going to be B. And again, this will be H. And I'll try to draw this so you can see both the red and the black. All right. Yeah. Maybe you can. Not too bad. So, if A equals H, or in other words, A equals whatever B times sine A is, I get one right triangle. Now this is the part that gets a little confusing. What happens if I stretch this side a little bit further? So I'll try to draw that again. So one more time, here's my angle A. This is my side B. And again, this is my height. And please notice that I'm not trying to I didn't measure anything. I'm just giving you ideas here, okay? If I pull, go beyond, I had it short A, perfectly the same as H, now it's going to go beyond H. Well, it's going to end up down here someplace. That's not on the triangle, or that's not on this side. So what I have to do is I have to swing it over here to connect. This side is bigger than H, so that would be side A. But now here's the part that I really need you to pay attention to. If I swung it that way, I'm going to get that triangle. But if I swing it this way, I'm going to get another triangle. So, if H is less than A, and again this means B times sine A is less than A, I'm going to get two triangles. But there's one more thing I need to add here to this that's going to make sense when I write the last thing that's going to happen. Okay? So I'll come back and modify this one after I draw the last one. So I'm going to start off again with the same idea. Here's my angle A again. I think I keep making this bigger every time. Sorry about that. Here's my height at a right angle. But if I pull this side A down really far and swing it this way and it connects here, I'm going to make one triangle. And if I swing it the other way and it's going to be between here and here, then I'm going to get another triangle. But what happens if I pull it so far that it actually ends up over here? So maybe I have something like this. And if that's the case, and here's B, and if I swung this over the other way, it'd end up over here someplace. Here's A. If A is greater than B, or it even works if it's equal, I'm back to one triangle. And notice this one has nothing to do with the height, actually. I don't even need to talk about the height. It's just that if you know angle A and side B, if the opposite side is more than B, it's going to be way out here to the right somewhere. It's not going to come back the other way. Which means I have to go back and modify this one. This only works if it's less than B. All right, now there's two other things that are going to happen, but these are the four important things that we talk a lot about in class. Here's a summary of what we just said. Here's the four that I just talked about. Have this printed and nearby when you do this. And I'm going to go through the steps to do it, but it'll be okay. There's two other things that could happen. I told you that this is when angle A is acute. There's two other things that could happen. Angle A could be a right angle, all right? If that's the case, then A has to be bigger than B. If A is less than or equal to B, you get no triangle. So that's all you gotta check. If angle A is right, just make sure that side A is bigger than B, and you get one triangle. And then you can go use the law of sines to solve it. The other thing, same kind of idea. If angle A is obtuse, then it says, it's a little confusing here. It says if A is less than B, you get no triangle. All right. A better way of saying this would be if A is greater than B, you get one triangle. Forgot to rewrite that. And same thing if it's obtuse. If A is greater than B, you still get one triangle. So you just, for right and obtuse, angle A, you just check those two sides. And the side opposite has to be the biggest one. Now here's the steps. This is what we're going to do, all right? You've got side angle. First, you decide if angle A is going to be, these are easy. So first you decide if angle A is right or obtuse. Then you check which side is bigger. A has to be bigger than B. If that's the case, you got one triangle, boom, you got two sides, one angle, you can figure out everything else. Okay? And remember, you're going to use the law of sines because you're going to have an angle and its opposite side. If angle A is acute, then it's going to be one of these four choices. The easiest one is if A is bigger than B, just like these two. If A is bigger than B, you're going back to one triangle. But for all the other three choices, if A is not bigger than B, or another way of saying that A is less than B, you're going to have to compare side A to the height. And then if side A is less than the height, you don't get a triangle. If side A is equal to the height, you get one right triangle. And if side A is more than the height, but less than the other side, you're going to get two triangles that swing back and forth. There's a lot going on here, but it's okay. We'll get you through the whole thing. I'm going to do a couple of examples, but we'll do more in the guided practice, all right? So, this seems like an application problem, but it's not. We're just going to get to the triangle. Maggie's designing a mosaic using triangle tiles. That's all great. Very artsy, okay? We have these measurements here, okay? The measure of side A is 11 centimeters. Side B is going to be 17 centimeters. And the measure of angle A is acute at 30 degrees. That's the important information. So let's try to draw a picture. I'm not going to use a protractor to draw it exactly. I have this side going out this direction somewhere. And I'm going to try to draw approximately 30 degrees. This is angle A. On the opposite side of angle A, I'm going to have a side which I don't know how far it's going to go, so I don't trust my picture. It's going to be 11. It might, the end of it might be here dangling in space, or it might come at a 90-degree angle, or it might go beyond and I'm going to get two triangles, or it might go way beyond and I go back to one triangle. So it might look like this, 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 or this. We don't know yet. I do know that this side is going to be 17. So let's check what we do know, right? First of all, this is acute, so you can ignore these two. Let's do the easy one. Is side A bigger than side B? 11 is not bigger than 17. So I've crossed that one off, that one off, that one off. Now I need to figure out which one of these three is going to work. And what I need to know, I need to find H. So the height of this, again, I'll draw it in red. The height is going to be B times the sine of angle A, which is going to be 17 times the sine of 30 degrees. Now, you guys are good at this. You know the sine of 30 degrees is 1/2 or 0.5. So half of 17 is going to be 8.5. If you really want to do this with a calculator, because most of the time it's not going to be one that you've already memorized, 17 times sine 30 degrees, like I said, is going to be 8.5. So the height is going to be 8.5. And that means that the 11, actually, if this is 8.5, I should have drawn it further. Okay, whoops, sorry, I didn't mean to go beyond it. I should have drawn it further. Okay, that's great. So let's use the law of sines to figure everything out. So you got the measure of angle A, which is 30 degrees, and I've got side A, which is 11. The measure of angle B, I don't know yet, but side B is going to be 17. And once I get to angle B, I'll be able to figure out angle C and side C. Okay, so I'm just need a little bit of room to do what I'm doing here, okay? So I'm going to set this up as a ratio. I'm going to say the measure of angle B over 17. This is the law of sines. Oops, sorry. Sine of angle B. Sine of angle B is going to be the sine of 30 degrees over 11. And I'm going to multiply 17 times sine of 30. So 17 times sine of 30 degrees, which I already know, it's 8.5. But this time I'm going to divide it by 11. And I get 0.7727. That is not the angle measurement. Let me rotate that out a little bit. Whoa, sorry. I got some lights on here just to kind of like, so you can see it. Sorry for the reflection. That is not the angle. That's the sine of the angle. So what do? I do second sine, which gives me sine inverse. And on my calculator, if you want to retype it, that's fine. On my calculator, I can drop the previous answer in there, close your parentheses. And this tells me that angle B says round to the nearest tenth, so it's going to be 50.6 degrees. I know that all three angles are going to add up to 180. Please keep in mind that that is incorrect, because that is closer. That's not even correct because it goes just to more decimal places but doesn't go forever. But again, we're just estimating. So I'm going to do 30 plus 50.6, and I'm going to take 180 and subtract that. And the last angle is approximately 99.4 degrees. It's probably about 99.4006 or something like that, okay? So now we're going to use, again, the law of sines. C over the sine of angle C, 99.4. And again, I know that that's an estimation, so I have error in my math. And I've got 11 over sine of 30. So sine 99.4 times 11 divided by sine of 30, close your parentheses, and that tells me my last side is going to be 21.7. Okay, that's great. But guess what? I could have also have swung it over this way and end up with another triangle. So let's deal with this triangle, and we'll call this point B, and of course that's point C. So I've got the measure of angle A still 30 degrees. The measure of angle B, I don't know yet. The measure of angle C, I don't know yet. Side A is still 11, and side B is still 17. Don't know side C yet. Now, you're thinking, okay, if I set this up to solve for angle B, I'm going to use this over here, and it's going to give me exactly what I got here, which is not going to be different. So look at the picture. Check this out. This angle right here, the original angle B was going to be 50.6 degrees. That means that this angle right here, because that's 11, this is an isosceles triangle, these two angles are going to be congruent. That angle has to be 50.6 degrees. But that's not the new angle that I want, it's the angle on the other side. Those two form a linear pair, means they're supplementary. They add up to 180 degrees. So I'm going to take 180 and subtract 50.6, and my new angle B is going to be 129.4 degrees. Just put my degrees in there. Forgot to do it for that one. Okay. Now we're going to do the same thing, except this time, instead of right here where I'm going to use, I use sine B here. I've got sine B. Instead of using, I lost my place. Oh, now I got it. Sorry, I was getting ahead of myself. Now I can figure out what the new angle C is. The original angle C went from here to here. Now it just goes that part. So 180 subtract 30 subtract 129.4 gives me 20.6. And now side C over sine of 20.6 is going to be 11 over sine 30. So remember, I always go back to what I was given. And sine 20.6 times 11 divided by sine 30. And that gives me, rounded to the nearest tenth, 7.7. So because I got two different triangles, I had to solve both of them. Okay, we'll see you in the practice problems.